we're going to skip section 5.5 and 5.6. 5.5 looks at a concept that I don't want to talk about at all. 5.6 is a review section, so it would actually be pretty good if you go to WebAssign and you look for those problems, those practice quizzes. It'd be a good thing for you to try and do. Just ignore anything that has a cubed power, because that would be 5.5, which we didn't talk about. Otherwise, any of the other familiar types, definitely try and factor those. But there's nothing new, so there's nothing for me to cover, so I skip it. And next up is 5.7, where we get into solving by factoring. The basic idea here, so before I talk about the problem I've got up on the board, the basic concept is you want to try and think of any way that you could multiply two values and get 0. That's going to be the trick for all of these solving by factoring problems. You're thinking about how you can multiply two things and get an answer of 0. Go through real quick in your head, think about all the different numbers you could multiply, but you have to get 0 as an answer. As you're doing this, you should realize the only way that happens is if the first number you choose is 0, or if the second number you choose is 0. That's the only way it works. That's the assumption, that's the logic we use when we solve by factoring. So what we try and do is get our problem into this form where we've got our parentheses or whatever, we've got all these things, all these factors multiplied together, set equal to 0. That's equally important. You have to have the equal 0 on the other end so that you can say, well, either the first factor is equal to 0, the same way that your first number had to be equal to 0, or the second factor is equal to 0. That's the only way that you can multiply two things and get 0 out of it in the end, is if the first one is 0 or the second one is 0. In each case, you get an answer. You go through and you solve the equation for each of them, and you've got two possibilities for x right there. That's all there is to it then. That's what this whole section is going to be about. Now the downside is it's not going to start as a factored problem for you. You're going to have to try and solve something like x squared minus 9 equals 0. And so what you're going to have to fight is the impulse to move the 9 to the other side. I know it's what we practiced whenever we're talking about linear equations, but notice this is no longer linear. We don't have just a single x. So whenever you move up into the x squared, you have to treat it differently, you have to work with it differently. And the only thing that we can do really, or the next thing you should recognize, I guess, is that this is the difference of two squares. So right away I'm hoping your brain thinks about that, pulling it apart into x minus 3, x plus 3, which is good, because now we've got things that are multiplied, we have it set equal to 0, so the next step of it, the new step here, would be taking each one of the factors and setting them equal to 0, and then going through and solving each one of these factors to get two possible answers. From here, all that changes is the factoring gets more complicated. Let's take 2x cubed equals 8x and try and work with it. One of the big keys is the equal 0. You got to have it. That's what we used on the last two problems. That's what we're going to use on all the problems. So if you've got terms all jumbled around everywhere on both sides, you have to move them all over to the same side. So I'm going to subtract 8x from both sides of the problem here, just to get equal 0. From there, I have to try and figure out how to deal with the left side of the problem, how to pull it apart, or how to factor it. I noticed that there are x's on both terms, gets me thinking about GCF. I noticed that there are also 2's on both of them. So I'm going to factor a 2x out and see what happens. From there, I notice x squared minus 4. Well, I recognize that. That's the difference of 2 squares, so I'm going to keep factoring it. I've got the 2x, the benign tumor in front. The x squared minus 4 becomes x minus 2. X plus 2 equals 0. And nothing changes if you have 3 different factors versus 2 factors. There's no change in the logic. The only way you multiply stuff together and get 0 is if the first thing is 0, or the second thing is 0, or if it's there, if the third thing is equal to 0. And you can just keep going with this logic. If you have 4 things multiplied together, you set 4 things equal to 0, and you go through and you solve each one of them until you get all of your answers. We can do this with trinomials as well. So part C, x squared minus 2x minus 15 equals 0. You think about how to factor a trinomial in this case. Well, it's rules that we've talked about and learned. You need to find something that multiplies to negative 15, adds to negative 2. Negative 5 times 3 gets you negative 15. Negative 5 plus 3 gets you negative 2. So this thing factors like this, which means you can then take each factor, set it equal to 0, solve each one of those factors, and get your answers. You could do this with AC method. Still have to have equals 0. That's going to be a fundamental role for this whole section. So if you're solving, you have to have equals 0 over here. Whatever else happens, you got to move it over until you get equals 0. And then you look at what you've got on the left-hand side, you factor it according to whatever rules. So you should kind of, in your head, have this little Rolodex of different methods. You've got GCF. There's nothing common, GCF is out. You've got grouping. It's not 4 terms, grouping doesn't work. You've got difference of 2 squares. More than 2 terms, doesn't work. You've got basic trinomials. There's a number in front of the x squared, basic trinomials is out, AC method, that's what you got left. So you got to make AC method work. 3 terms, number in front, seems to fit, so you take A times C. I know I just went through that whole rigmarole pretty quickly, so maybe rewind the video and listen to it again. That's what should be going through your head on every single problem. GCF, grouping, difference of 2 squares, basic trinomials, AC method. You should start to kind of see it in your head. That's just the highlights that are coming by. Pick the one that works, start using it. In this case, stuff that multiplies to 4 and adds to negative 5. Just keep factoring like we talked about. Set each one of the factors equal to 0. Solve each one of the factors. If it ends up being more complicated, well, go back and remember how to solve different equations. We've definitely talked about stuff like that, so it shouldn't be too bad to get 2 and 1/2 for that problem. Okay. 2 more that I'm going to put up here, and I'm going to let you guys do these at home, kind of guided practice problems again. I'll give you a little bit of hint on them, and I'll give you the answers. You guys fill in the work in between, because I think I've done the factoring discussion pretty well here, so. Alright, so with this one over here, 15x squared minus 20x, should be thinking GCF. You notice that there are at least x's that are common. That should be how you factor it. The other thing you might notice is that there's a minus sign, there are 2 terms, so maybe some difference of 2 squares are going to play into it, maybe not. Start with GCF, see where that takes you. You should wind up with x equals 0 and x equals 4/3. Those should be your 2 answers there. Part B, again, start with GCF, always start with GCF. Notice there's nothing common between all the terms, so you have to go to something else. You notice there are 4 of them. 4 of them means you have to go with grouping. So try and factor it by grouping. Calculator would be handy here because the numbers are a little bit big on those last two, but still doable. There will be a difference of 2 squares in here. So this problem will definitely have to be factored that way also. You should wind up with answers of -2, 9, and -9 for this problem. Otherwise, that should take us through 5.7.